the sine, cosine, and tangent of an angle is simply another way of saying certain ratios inside of a right triangle. First off, sine, we know, is equal to opposite over hypotenuse. We need to define what opposite and hypotenuse actually means. We know the hypotenuse is always the side across from a right triangle, or right angle, excuse me. And also, if this is the angle that we're discussing here, and we call this angle theta. Theta is like an x, like an unknown. The side across from theta will always be called the opposite side, and the word adjacent actually means next to is the other of the two legs. So again, opposite is across from, adjacent is next to, and we all know what the hypotenuse is. The sine of an angle is simply the opposite side over the hypotenuse. The cosine is adjacent over hypotenuse. The tangent is opposite over adjacent. So we use sine, cosine, and tangent to find missing side lengths or angle measures inside of this right triangle. First off, we identify what kind of triangle or what kind of problem we have. Here's the angle in question. We all know that this is a hypotenuse because it's across from the 90-degree angle. And this side, this leg here, is adjacent because it's next to. So therefore, since we're dealing with A and H, this is going to be a cosine problem. So we know the cosine of the angle, we'll always have sine, cosine, and tangent of an angle is equal to adjacent over hypotenuse. Now it's a simple one-step problem. To figure out what x is, we simply mark out our 15. Since it's being divided, we move it to the other side by multiplying. And once we type in 15 times the cosine of 59, that'll tell us what our answer is. Number 4 here. Again, here's our angle in question. This one's slightly different. We all know that this is the hypotenuse again. And this is now the opposite side. So therefore, opposite and hypotenuse, we are now dealing with what's called a sine problem. The sine, abbreviated SIN, of an angle, again, we always find sine, cosine, and tangent of angles, is equal to opposite over hypotenuse. Now this one's slightly different because now we have the x on bottom. Anytime we have the x on bottom, we can use this shortcut. We can simply switch the sine 28 and the x. And we have now that x is equal to 11 divided by the sine of 28. And again, once we type that in, that tells us our side length. And finally, the third type of problem we could have. Now we're looking for the actual angle itself. And we know, let's work this one. We know that the hypotenuse is always across from 90. This is next to the angle, so that's your adjacent side. So this is another cosine problem. The cosine of your angle is equal to adjacent over hypotenuse. Now, in order to get the theta by itself, we're going to use what's called inverse cosine. We mark the cosine out. We go to the other side, and we use, on your calculator, usually you'll hit the second button first, and then hit the cosine button, and you'll type in the second cosine of 12 over 13, and that'll give you the angle in question. We'll work one more of those because we've not seen a tangent yet. In this problem, here's the opposite and adjacent legs. We do not have anything, we don't know anything about our hypotenuse here. So opposite and adjacent, again, this is called a tangent. The tangent of my angle is equal to opposite over adjacent. Again, to get that angle by itself, we move the tangent over by doing inverse tan, or second tan of 4/13, and that'll give us the measure of our angle.